going to do now question number 3. Under suitable conditions, 2-bromobutane reacts with sodium hydroxide, produce a mixture of 5 products, A, B, C, D, and E. Okay, let me just put this correct like that. So, right, so we got A is a structural isomers B and C. So this is the information. So they say products A, B, and C are all alkenes. They are alkenes. So you know they're alkenes. A is a structural isomer of B. So it's an alkenic structural isomer. A does not exhibit a stereoisomerism. B and C are a pair of stereoisomers, like cis and trans or EZ isomers. Products D and E are alcohols. Okay, give the names of 2 concurrent mechanisms responsible for the formation of alkenes and alcohols. So for alkenes, it's called elimination, okay, because you got the bromo, which is a haloalkane. You need to know this reaction. It reacts with sodium hydroxide in ethanol, I think, and then it undergoes elimination reaction. So you warm ethanol, that's correct. So mechanism for form alcohols is a nucleophilic substitution reaction. So that's aqueous sodium hydroxide. Right, define the stereoisomers. So you have to know the definition of that. So there's not much you can do apart from learning. It's a molecule that has the same structural formula but different spatial arrangements of atoms. Deduce the name of the stereoisomer A. Why? Explain why it does not exhibit stereoisomerism. So from this information says A is a structural isomer of B and C, and A does not exhibit stereoisomerism. So A has to be butanene. Butanene has got 2 same groups attached to the carbon-carbon double bond. So this one's got hydrogen, and then it's got the alkyl group there. And this one is only got 2 hydrogen. So they're the same, so they can't form stereoisomerism there. So explanation has 2 groups of atoms on the same side in one of the CC double bonds. Okay, so that's the reason for that. Because to be a stereoisomer, they have to have 2 different groups attached to it. Right, let's do the next one. So 3.4. 3.4, outline the mechanism for the reaction of 2-bromobutane with sodium hydroxide to form alkene A. So you know it's elimination reaction, so you have to know the mechanism. So the OH is here, the lone pair is attracted to the hydrogen. So that bond breaks, forms a double bond there, and that Br leaves. So you can see double bond there. Br leaves, H plus leaves, and that's the A, which is no stereoisomerism in here. Okay. I just wonder if I've done this correct. Let me just check. Yes, that's correct. So I just got a bit, in doubt there. Sorry about that. Okay, deduce the name of isomer B and name of isomer C. Explain the origin of the stereoisomers B and C. So you got B and C. So what we know about B and C, it says here B and C are pair of stereoisomers, okay? So they've got the same, so it has to be EZ isomerism or cis and trans, okay? So B is a Z butene because the isomerism of B, so it has to have, 2 different groups attached to it. So it has to be butene. So it goes Z and E. So why is that? Because there is a restricted rotation around the carbon double bond, okay? So that's the explanation for that. Draw 3D representation of enantiomers D and E to show how their structure are related. So it says here D and E are a pair of enantiomers, so they form optical isomerism. So if it is, if you have binucleophilic substitution, you form this alcohol. And then if you take this alcohol and you put in an optical format, which is 2 straight bonds and one away and towards you, and then you just do mirror images of each other. So that's the molecule, and then that is in the form of optical isomers. I hope that's clear for you. And the last one here is an experiment. So a student compares the rates of hydrolysis of 1 chlorobutane, 1 bromobutane, and 1 iodobutane. The suggested method is add equal volumes of 3 halogen alkanes to separate test tubes, add equal volumes of aqueous silver nitrate to each test tube, record the time taken for the precipitate to appear in each test tube. Explain and state and explain the order in which precipitate appears. So the most reactive one is going to appear first. So silver iodide is going to be forming first because it's got a weaker bond and a longer bond, I think. Yeah, it is. and silver bromide comes after, and silver chloride is the last one to appear because you got the stronger bond. So explanation, the bond strength of the Ci is weaker than the CBr, than CBr. Then you got the CBr is weaker than CCl. So therefore you got Ci is weaker than CBr, which is weaker than CCl. I hope that's is clear. So yellow precipitate, cream precipitate, and white precipitate will be observed in this way. Okay.